Hello, class. In this particular lesson, we're going to go through section 2.3, which is going to be on the algebra of functions. So, the domain of these functions that model did typically have the domain stay with the equation, but not every single one. And for the most part, the domain should be the largest set of real numbers for which our function is a real number. So, like, for example, for 2 divided by x minus 4, we have all real numbers almost everywhere. It's just that this denominator cannot be 0, which means x cannot be 4. So our domain for this would just be negative infinity to 4, union 4 to infinity, with that 4 in parentheses. But f of x is equal to the square root of x plus 1. The 1 doesn't matter in terms of the domain. Due to that square root, we can't have a negative. Could be 0, just not negative. So 0 to infinity, including the 0, so bracket around that 0. So the formal process of finding this particular domain will specify that domain's function is the largest set of real numbers, where this function is a real number. So we want to exclude division by 0, taking the square root of a negative number, that type of thing. So this first one, I want the domain of f of x is equal to 6x plus 9. That's a function, a polynomial function. This exists everywhere. Nothing is stopping it. So negative infinity to infinity. For this one, f of x is equal to 1 over x minus 13 plus 1 over x minus 3. We want the domain here, so we cannot have a 3, and we cannot have a 13. So negative infinity to 3, union 3 to 13, union 13 to infinity. It's going to be our interval for the domain, and all those numbers are in parentheses since we do not want to include that number. So per the name of this particular section, algebra of functions, we have these 4 total operations that we could use. And then we could find the domains of these new functions, which for the most part, most of them shouldn't differ that greatly. But the sum f plus g of x is f of x plus g of x. Just like the difference, f minus g of x is f of x minus g of x. Product f times g of x is f of x times g of x. F divided by g of x is f of x divided by g of x. G of x cannot be 0. So example number 3, I have let f of x be 5x minus 2, g of x be x minus 1. We want f plus g of x. So 5x minus 2 plus x minus 1. So 6x minus 3. And then we want to pop 5 in for that x. 6 times 5 minus 3, so 30 minus 3, that being 27. Number 4, let f of x be equal to 13x, g of x be negative 2x minus 4. We want f plus g of x. We want the addition, subtraction, multiplication, and division instead of me just reading it all out. F plus g of x. 13x plus negative 2x minus 4. So 11 minus 4, 11x minus 4. The f minus g of x, 13x minus negative 2x minus 4. So 15x plus 4. Then for the multiplication, f times g of x, 13x times negative 2x minus 4. So negative 26x squared. Negative 26x squared minus 52x. And then f divided by g of x. We can't simplify this. 13x divided by negative 2x minus 4. You could technically factor out a negative 2 from the bottom, but it's not ultimately that necessary. But due to this, we cannot have x here being a value of -2 when we set that denominator equal to 0, which would be the only additional restriction in that domain. So number 5, for the functions f of x is equal to 1 over x, g of x being 3 over x minus 5, we want the domain of f plus g, which we could technically find without having to add them, but I'll put the addition here, which we can't really do too much with. But 1 over x plus 3 over x minus 5. We could certainly combine these, but you don't need that to know the domain. So we can't have 0 and can't have 5. So negative infinity to 0, union 0 to 5, union 5 to infinity, excluding the 0 and excluding the 5. For example, number 6, let f of x be equal to x squared plus 7x, g of x be 5 minus x. Let f divided by g of x and f divided by g of 4. So this one also, I cannot simplify this. X squared plus 7x divided by 5 minus x. We could factor on x in the numerator, but quite frankly, it's not going to reduce anyway, so I'm not going to write that out. And f divided by g of 4 makes 4 squared plus 7 times 4 divided by 5 minus 4. So doing that is going to give us 44 divided by 1, so 44. Number 7, we want these graphs to find f of g of 1. So at 1, g here is 0, f is 3, so 3 times 0. Well, I probably should be consistent, shouldn't I? 0 times 3, and 0 is for f, 3 is for g. This makes 0 for the product. And number 8, f of x be equal to x squared, g of x to be 3x plus 1 over 2, and h of x to be x plus 5. And we want to do these operations. So f times g of x would be x squared times 3x plus 1 over 2. So that is going to be 3x cubed plus x squared divided by 2. H minus g of x will just be x plus 5 minus 3x plus 1 over 2. We're not going to attempt to combine those, so we'll just leave that the way it is. F plus h of x will just be x squared plus x plus 5, and g divided by h will be 3x plus 1 divided by 2, that divided by x plus 5, which we could simplify this a bit. This is the same thing as 3x plus 1 over 2 times 1 over x plus 5. So 3x plus 1 over 2x plus 10 for this particular case. So let me know if you have any questions or concerns. Thank you.